Okay, so today we'll finish up section 6.3. We're going to start off by looking at multiple transformations. Okay, so anytime you have multiple transformations, we've talked about the order quite a bit. So I'm going to put down kind of just generically an equation, and I want you to tell me what each transformation is. So let's have sine bx plus a, put a c in the front, plus d on the end. The order, the letters that I wrote, I put them in the order you should do the transformations. A, then B, then C, then D. Okay. And if we're matching them up with numbers, it's 1, 2, 3, 4. Okay. What's the first transformation there?
Left 2. Or left.
In general, because we don't have a specific number. We just have an A.
Yeah, left.
Left or could be right.
Yeah.
And what do we call that one? It's a phase shift. Okay. How about the second transformation? What is that one? What's your period change? You multiply by a number in front of x. Phase shift and period change both affect which axis? The x-axis. Okay, so those are all your x-axis transformations. Always do the x-axis first, and in that order. How about 3? What kind of transformation is that one? What kind of stretch? Vertical. Yep. So that's your vertical stretch. And what did we call that? Vertical stretch changes the y's, but what do we call that on the graph? The height of it. Amplitude. It's an amplitude change. Yep. So vertical stretch, or you could call it amplitude change. And the last one. What's the fourth transformation? Up, or it could be down, and that's a vertical shift. Okay. So if you have a problem with multiple transformations, that's the order you do them in. You just do one at a time. Okay. Questions on the order? Or being able to identify which transformation is which. If you copy this down, that should tell you everything you need.
1 and 2 changes the x-axis. 3 and 4 changes the y-axis.
1 and 2 affects the x-axis. 3 and 4, that's all the vertical stuff. That's the y-axis.
Okay.
Yep. X-axis, y-axis. Great. So let's graph this one. So in order to do it, we're going to do it in 2 steps. We have to pick which transformation to do first. Do that, get the table, and then use that table to do the next one. Okay. So what number here am I going to focus on first? The 2 or the pi over 2? The pi over 2, yes. What does the pi over 2 do? It's a phase shift. Phase shift is going to change what values? The x. So for now, we're going to keep the y's the same. If you want to try to change the y's at the same time, you can, but I'm going to do one at a time. So keep the y's the same. Now, take all your x's, pi, 0, pi over 2, pi, 3 pi over 2, 2 pi, and what am I going to do to all the x's for the phase shift? Exactly. You have to do the opposite. Some people forget about that. Subtract pi over 2. As far as doing the work off to the side, I'm not really looking at the work. I'm looking at what you get for the final answer. Okay. What's 0 minus pi over 2? Negative pi over 2. Pi over 2 minus pi over 2? 0. Now the next one is pi minus pi over 2. What's the common denominator? 2. 2. 2. 2 pi over 2, take away 1 pi over 2. Chris?
Pi over 2.
Yep, pi over 2. The next one, we already have a denominator. 3 pi over 2, take away 1 pi over 2.
2 pi.
2 pi over 2, which we can make pi. So we had negative 1 pi over 2, 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay. And now we've done that. Any questions on the first table? Okay, now second table. We're going to use the table we just had. Don't go back to the original in your notes. We're going to stick with this table. But now we have to figure out what the 2 is doing. What is the 2?
Moving it up.
Stretching
it
So it's
up
going to be a
to-
vertical shift.
Not a shift.
Or,
A vertical stretch.
Stretch.
Sorry.
Vertical stretch. So what's going to change when you do something vertical?
Right.
The height, which is which axis?
The Y.
The y's. So the x's are going to stay the same for this. So copy down your x's from the table because they are not changing this time. So negative pi over 2, 0, pi over 2, pi, 3 pi over 2. Now, what are we going to do to all the y values? What's the arithmetic we need to do?
Multiply.
Multiply them by
2.
2, double them. So we get 0, 2, 0, negative 2, 0. And that's the final table. Okay. On the test for a problem like this, I'm not going to grade the first table and the second table. I'm just looking at the final answer. What'd you get for the x's? What'd you get for the y's? Okay. 1 point for each x and y. Okay. And now we'll graph it. Okay, look at the table. Am I skipping 0 in the x column for the final table? No, there's a 0 in that column. I'm not skipping over it. So that means when I set up my grid, I don't need to skip anything. The only time you skip is if you skip 0 in the table. Then you have to skip every time. Okay. So here's negative pi over 2. 0 is the axis. Pi over 2. Pi. 3 pi over 2. For your y-axis, I'm going to make my marks go by 2's. 0, 2, negative 2. If I didn't label my y-axis and just left it blank, what am I going to assume you're going by? 1's. Okay, but I want to go by 2's. Now graph your points. So we're at 0, 2, 0, negative 2, back to 0. Okay, so we have a sine function that's been shifted to the left, and it's been stretched by a factor of 2. Now if you look at it, you might be like, well, it doesn't look like I stretched it. It doesn't look taller than usual. How come? Why doesn't it look taller? Yeah, because I scaled it. I changed my scale. That's why it doesn't look taller than usual. Okay. So that's a multi-step transformation problem. Any questions on that? Okay, I don't really think it's harder. It's just longer because you have to do one and then do another one. You're doing 2 in a row instead of just 1. All right, let's try this one. So 3 cosine 2x. Ezekiel, what number do I have to focus on first here? Yeah, the 2. You start with what's in the parentheses. Can you tell me what the 2 is going to do? Yeah, horizontal stretch, or in this case, it's actually going to compress. Remember, big numbers compress. So if it's horizontal, what values are not affected at all? The y's. Copy those down. Unfortunately, in this kind of problem, if you make a mistake on the first table and you copy that to your second table, well, now the second table is wrong too. So copy the y's correctly. Okay, and Ezekiel, we're going to take all the x's and do what to them? We're going to divide them by 2. Dividing by 2 is the same as multiplying by 1/2. I'm going to think of it that way. 0 times 1/2. Caitlin, what's my next x value after 0 normally?
Wait, after 0?
Yeah,
It's pi over 2.
pi over 2. And if we take half of pi over 2, that gives you
2 pi over 2.
Pi.
pi over 4. And then the next one would normally be pi. And if we take half of it, pi divided by 2. Next one after pi,
Pi squared. I mean, pi by 2.
3 pi over.
3 pi over 2. Take half of it,
2 pi over 4.
3 pi over 4.
3 pi over 4. And now look at the pattern with denominator of 4. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4.
2 pi over 2.
Just pi.
Just pi would be 4 pi over 4, which is just pi. Okay. So that's that part. Okay. Now we got to deal with that part. What's the 3? What kind of transformation is that? Vertical stretch. Yep. Vertical is going to change which values? So that means which ones stay the same? X's stay the same. So copy down the X's you just created. We got 0, pi over 4, pi over 2, 3 pi over 4, pi. And now, what am I going to do to all my y's?
Multiply by 3.
Yep. What do I get if I multiply them all by 3?
3, 0, negative 3, 0, 3.
3, 0, negative 3, 0, 3. There's your table. Any questions on that? Right, now let's make our sketch. I'm going to label my y-axis by 3's. My x-axis, did I skip 0? No. So if I don't skip 0, I'm not going to have to skip anything. So let's put our labels. 0, pi over 4, pi over 2, 3 pi over 4, pi. Okay. So this is going to look kind of like the V shape. Okay, but remember, it's more curved. So 0, 3, 0, negative 3, 0, and then pi, you're back up at 3. There's your sketch. Any questions on it? Okay, so that one combined a period change with a vertical stretch. The one we did before combined a phase shift with a vertical stretch. Let's do something different. We haven't done a vertical shift yet. So let's combine a vertical stretch with a vertical shift. This is the first time I've given you a problem that affects only one axis. In this problem, we change the x's and the y's. In this problem, x's and the y's. And technically, I didn't tell you this because I don't want to confuse you. If you're only doing one transformation on the x-axis, one transformation on the y-axis, you could do it in either order because they're two separate axes. Here, it's very important we follow the right order. Because think about if you multiply a number by 4 and add 2. Right? If you do it in a different order, you get a different answer. Okay? Take a number, 6. If you do 6 times 4 and add 2, or if you do 6 plus 2 first and then times 4, do you get the same thing? No. In the top one, you get 24 plus 2. In the bottom one, you get 8 times 4. It's not the same. Right? So when you do two transformations on the same axis, you have to do it in the right order. Okay. So we already know I said to you it's going to be y-axis. What number do I focus on first? The 4. We're going to multiply the y values by 4 first. And what's nice about this is you don't have to mess with the x's the whole problem. They're going to be the same. 0, pi over 2, pi, 3 pi over 2, 2 pi. There's your x's. Okay. Actually, no, I'm not going to put a box on that. Can somebody tell me what my new y's will be?
0.
Yep.
4, 0.
0, 4, 0. Negative 4, 0. Okay. Right, so now we've done the vertical stretch, and now we're going to shift everything up 2. So to shift up 2, what do we do to all the y's? We add 2. We don't do the opposite. Don't subtract 2. Okay. We do the opposite with a phase shift. This is not a phase shift. So x, y, 0, pi over 2, pi, 3 pi over 2, 2 pi. Now add 2 to all the y's. Julia, can you tell me what I get if I add 2 to all the y values?
2, 6, 2, negative 6, 2.
So 2, 6, 2, and what's negative 4 plus 2?
Negative.
Yep, negative 2. If you went to graph it, you would notice you made a mistake with one of them because you'd have a bunch of nice points, and then one of them would be really far away from all the others. Okay. All right, let's see. So I look at my table. Am I skipping, bless you, did I skip 0? No? So if I didn't skip 0 in the table, I don't have to skip it on the graph. So I'm not going to skip anything. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And on my y-axis, I'm going to go by 2's. Okay, so graph your points. 0, 2, pi over 2, we're up at 6, pi, we're back at 2, 3 pi over 2, negative 2, about right there, and then 2 pi, back at 2. There's your sketch. Okay, what's the amplitude of that graph? Yes, the amplitude is 4. What's the highest point the graph ever hits? 6. That's a different question. Sometimes those two questions would have the same answer. In this case, they have different answers. What's the period of that?
1.
So the period is how far it goes before it repeats itself. 2 pi, we didn't affect the period at all. Remember, period change would be right inside there. Would be the number in front of x. There's no number in front of x other than a 1. Any questions on that? So there could be some questions on the test where I just ask you, what is the period? What is the amplitude? Would you ever say amplitude is negative?
No.
No. What if I did that though?
No, it's the
No.
absolute.
No. All that would do is take this graph and flip it around that way. It would just mirror image it, but it does not change the amplitude. Good. Directions here. Find a complete graph. What does that mean to do when it says find a complete graph? Graph it. Not by hand, but on the calculator. So find a complete graph, and then find the domain, the range, amplitude, and period. I kind of did part of that with you in the last problem. I asked you what the amplitude and period were. And I did ask you what's the highest value, but I didn't ask for the lowest. Okay, so range is the highest and the lowest. Okay, so let's graph it. So we got 4 sine 3x. If they don't specify how many periods, how many cycles they want to see on the screen, zoom 7 is a good place to start. Sometimes it's going to go off the screen. I think this one just barely stays on the screen. Okay, it doesn't go any higher than lower, but if that number in front was a 5, then we'd have to adjust our window a little bit. Okay. So let's start with amplitude. In fact, you don't even need a graph for that. You should be able to just look at the equation and tell me amplitude. What's the amplitude of that? 4. Yep. Amplitude. Okay, so we got that. Period. Okay, what's the formula to find the period again? It's a fraction. 2 pi over whatever b is. What's b in this case? 3. So the period, 2 pi over 3. There's your period. Next thing, range. What's a simple way to describe the range? Like if somebody didn't understand the concept of range, what does range mean?
Limit on the x-axis.
Not the x-axis, the y. How high and low? What's the highest and the lowest that the graph goes? 4, -4 is the lowest. And it does actually reach it. Okay, if you wanted to confirm that, you could do second calc minimum on any one of those and find the minimum, but it will be at -4. And the maximum? 4. You could confirm that the same way. Do second calc maximum, and you would see it does hit 4. And lastly, domain. So domain, that's left and right. How far does this graph go left and right? Infinity, right? It doesn't stop. In fact, all sine and cosine functions go left and right forever. Can we reach infinity though? No, so that's why I put a parenthesis. So there's your domain, range, period, amplitude. Again, I think most of that you could figure out, at least some of it you could figure out without a picture. Sometimes range you might need a picture, but it's up to you. Great. So take a second and try that one. Graph it. See if you can figure out domain, range, period, and amplitude. If you can do some of it without graphing, that's fine too. Maybe just try graphing. All right, so let's take a look. Is there any one of those 4 things that somebody could tell me you didn't even really need a graph to do it? Mina?
The amplitude.
Yeah, what's the amplitude? 3. Right? Amplitude is the absolute value of the number in front. There's your amplitude. Anything else you can tell without graphing? Yeah, the domain. What did I say the domain always is? for sine and cosine, it's negative infinity to infinity. You can stretch negative infinity, you can compress it, you can shift infinity, it's still infinity. Right? Even the period, if you know the formula, you should be able to do that. It's 2 pi over b. What's b in this case? 1. I didn't put it, but it's right there. What's 2 pi divided by 1? 2 pi. That means there is no period change in this problem. So 2 pi. Now let's graph it and see if we can get the range. I mean, you could probably figure it out because if you know sine normally goes from -1 to 1, and you triple that, you should kind of know what it's going to go between now. So 3 sine x minus 1. So 3 sine x minus 1. Okay, so what's the highest and lowest that it's going now?
The highest or lowest?
Both.
Negative 3 and 3.
Negative 3 to 3. Yep. If you weren't sure, do second calc minimum or maximum, and you could check that. What's that -1 doing? It didn't really affect anything in this problem. Which way shift?
To the right.
To the right. It's a shift to the right 1 unit. Okay? But if you got rid of that -1, the amplitude, the period, domain, and range would all be the same. It had no effect on the problem at all. Alright, last thing we're going to look at. So, in algebra, you solve equations all the time. Well, in trig, we also sometimes have to solve equations using all the same rules you've used in algebra. Factoring, quadratic formula, except now we can do all of those things with trig. In this section, we don't really focus on solving trig equations with anything except a calculator. Later on, I think it's maybe later in this chapter or chapter 7, we go back to trig equations and solve them using algebra. So we'll worry about that later. Now, there's really not much for me to explain here because of things I've already taught you about the calculator. Does anyone have a guess how I could type this in so I could solve it on the calculator? And we've done this kind of thing a lot before.
Sin x divided by 0.4.
You don't even have to rearrange it. You can leave it exactly the way it is. You don't have to rearrange anything. Okay, so what is this thing called? That thing I just circled, that's it. What is it? Oh, it's an equation. Yeah, it's an equation. So we have an equation, and to make something an equation, what do you have to have in it?
An equal sign?
You have to have an equal sign, and then because you have an equal sign, that splits it into 2 sides, right? You have a left side and a right side. So we have a left side and a right side, and I want to know where the left side equals the right side. How could I type that in visually and see where 2 things are equal?
Oh, because you have y1.
Right, type it in into y1 and y2. Put sine of x in y1, or y2, or y anything, it doesn't matter. Put 0.4 into the other one. But now they've told me something else. What is what I just underlined? What does that say?
0 is less than or equal to x, which is less than or equal to 2 pi.
Less than 2 pi. Yeah, no equal on the
Oh,
second
I
one.
can't really see it.
So that's telling me what they want my answer to be between. Right? Because when we graph this, you're going to get a wave, and you're going to get a horizontal line. How many times does a sine wave and a horizontal line cross?
Infinite.
Infinite. There's infinite amount of answers to this problem. They're telling me only give the answers that are between 0 and 6.28. Those are the only answers they want. If there's any answers beyond that, which there are, ignore them. So, in your window, don't look beyond 0, and don't look beyond 2 pi. Now let's hit graph. So any intersections that we get on the screen, we're going to calculate. Okay, how many intersections do we get? 2. Okay, how do I find an intersection? What do I do?
Trace intersect or second calc intersect.
Second calc intersect. So pick a point somewhere on the blue, somewhere on the red. Does the guess matter?
Yes,
Why?
because there's more than one.
Yes, wherever I put the guess, it's going to give me the one that's closer. So it tells me one solution is 2.73. 2.73. And we get one more. Okay, do the intersect again. But this time, how am I going to get the calculator to give me the other one? What do I have to do?
Open the window.
What's that?
Open the window.
I want to keep the window the way it is. I've got to keep it between 0 and 2 pi.
You should put your points closer to the other intersection.
Yeah, not the first curve or the second curve point. That doesn't really matter. What matters is the guess. Okay, we've got to move that closer. That should probably be close enough. And now it gives me the other one. So the two answers here are 2.73 and 0.411. Now, when Hannah read this off earlier, I kind of made a point of saying the second one didn't have the equal to. That's because 0 and 2 pi are repeats. So you only include one. Think about 0 and 360. If you're going around on a circle, 0 and 360 are the same spot on a circle. So if you include 0, don't include its duplicate, 360. Okay? That wasn't an issue in this problem anyway, because they're not even close to crossing over there. But if they did cross right at the beginning, right on the edge of the screen, I would include that one. But I would not have included the one on the right edge, because it said not to. Okay. Any question on that? So two solutions. Okay, the restriction on this problem is the same as the last one, between 0 and 2 pi. I just wrote it wrong. Right, so Ian, can you tell me how to solve this one graphically?
You plug the left side of the equation with one slot and the right side of the equation together.
Yep. So we got 2 cosine. For me to type a half, it's easier to just do 0.5 rather than try it as a fraction. And 1.5. Okay, my window is already set from the last problem, so you don't have to change that at all. Okay, so how many intersections do we get here? Why?
One.
Yeah, just one. So sometimes you might get 2, sometimes you might even get 3, 4, 5. Depends on the problem. But in this case, I only get 1. Second calc, intersect. Since there's only one intersection, just hit enter 3 times, and it'll find it. Here's your answer. Okay, if you're wondering, well, how could you get 4, 5, 6 solutions? I can show you that very easily. Just change one number. And now when you get the horizontal line in the curve, it's going to cross a bunch of times between 0 and 2 pi. And there's a pattern to the solutions. Like once you find the first one, the next one reoccurs at regular intervals. So eventually we're going to come up with a shortcut to find them all without doing intersect every time, okay? Because they reoccur regularly. So we can use that to help us. All right, all right, let's do this one. What's different about this one compared to the last two we did? It's not an equation. What is that? It's an inequality. When you write an inequality, the answer is not x equals a number, or x equals a couple numbers. That's an equation. For an inequality, the answer is an interval between 0 and 3, something like that. Okay, but we start off exactly the same way. Put 2 cosine x into y1. Put negative 1.3 into y2. The limit on my window is the same as the problems we just did. That's not always the window, by the way. It's pretty common that that comes up a lot of the time, but not always. Okay, so we're looking for where the cosine graph is below the horizontal line at 1.3. In order to figure out where the graph in blue is below the one in red, what do I have to find? I need the two intercepts. I need the coordinates of these points. And then the answer, let's say this coordinate was a comma negative 1.3. Just, you could do second calculate intersect and figure it out. Say the next coordinate was b comma negative 1.3. Okay, I know it's negative 1.3 because it's on this line. So I know the y value, but I don't know the x value without doing it out. Where is the graph in blue below the graph in red? How would you describe it using what I have on the board? It would be any x value that is what?
Greater than A, less than B.
Greater than,
A.
let's see. Oh yeah, if we did it as a less than, sorry, I think I said it was less than. It's a greater than. So where is it above? Yeah.
When it's less than A and greater than B.
Yeah, less than A, and how much less than A can we go down to? We have a limit, we have a lower limit.
Well, yes, so it's 0.
0. Yep. So as long as x, actually I can write it as an interval. Anything between 0 and A. Now, I can include 0 because there's an equal to under it. Can I include A? Is it okay if these graphs are greater than or equal to, or is it strictly greater than? It says just greater than. At A, these graphs are exactly the same. They can't be exactly the same unless I put that. Okay, so anything between 0 and A, or what would be my next interval? Yep.
The parentheses and B.
Right, from B, but don't include B because that's where they're equal. It has to be strictly graded. From B up to how high?
2 pi.
Up to 2 pi. Can I include 2 pi? No. I cannot include 2 pi because there's no equal to under it. The only thing you'd have to do is do out the intersect and find what a and b are. But that's your answer. Now if they wanted it the other way, strictly less than, you would be between a and b instead of outside a and b. Less than would be between a and b. And that's solving trig equations on the calculator. Because all you have to do is find an intersect, even for a problem like this. You still just find your intersects. Any questions on how to find an intersect? Okay, so it's good. We wrapped up a little early, so you've got about 20 minutes. Okay, if you have a question on the homework, you can start it, and I'll try to help you. Okay, so homework, it's 346, 2 through 4, 7 through 9, 15, 17, 21 to 23, 29 to 31, 36 and 39. We'll go over that first thing tomorrow, and then we'll finish up everything that we need to know for the test on Friday.